Hello everyone. Welcome to Full Stack Development. Today we are going to discuss about different ways to create singleton pattern objects in Java. Like there are many ways to create singleton pattern objects in Java. So we are going to discuss about them. So mainly we will concentrate on these three things. Like we can create a singleton object by using class and enum also. In the class level, so we can create in two ways, like eagerly initializing singleton objects or lazily initialization objects. And also we can use enum to create singleton objects. So we will concentrate one on one. So in eagerly initialization, so what we can do is like we'll be having a static variable. So where we will create the object to that one and we'll directly initialize there only. And whenever an user request for the get instance method, so we'll return that instance. But the problem with this one is like whenever we creating the instance, if something happens, like if some error occurs at the line, like when we are initializing that one, so it is a problem. Like so we don't have any exception handling mechanism. So that's the one drawback of this one. The next one is the same eager initialization, but some little modified one. Rather than initializing the variable directly, so we'll use the static block and we will initialize the instance inside the static block by using the try catch blocks. Like if something goes wrong, so we can catch that exception and we can handle that exception. So in the eager initialization, these uh, objects will be created. That's a singleton object will be created during the class loading itself, and we will be having a single instance. The next one is the lazy initialization. So in this one, what is the drawback of the before one? Like if someone is not called the get instance method, there is a wastage of memory. Like we are actually creating the instance without on request. Like if someone is not asking also, we are creating it manually. So and object will be ready at any time. But in the lazy initialization, rather than creating the instance at the class level, class loading only. So we will wait for someone to call the get instance method. So whenever the get instance method is called first time, so then we'll check for the instance is created or not. So then we will create that instance and we will return it. So in this one, so yeah, we can actually create the instance, but the problem is like there will be a chance of two threads can call the get instance method at the same time, and so they will check for the instance is null, and if they are actually the request came at the same simultaneous time, so then there will be a problem like instance will be null and both threads will create the new instances. Then there is a chance of creating the duplicate one. So we will discuss that one by coding itself actually. So then we will go on how to break the singleton pattern and what are the remedies to overcome that breaking the singleton pattern. So we'll go and code for the first eagerly initialization, and then we will come to the lazy initialization, and we will see how it will works in different ways. So first I will start with lazy initialization. Sorry, eagerly initialization. As I said, like I will have a private static a variable called instance, and I will directly create object here only, and I will assign it to the instance variable. Sorry, static variable. So I will have a private constructor so that it cannot be accessed from the outside of the world. And I will have a public uh, method. So I will name it as a get instance and I will return the instance. So this is the first way of eagerly initializing the singleton pattern. As I told, like at the line number 4, so if there is an exception occurred while creating the object, so there is no way to handle the exception. So that's why in the next method, so we will actually modify some way to overcome this one. So for that one, so rather than creating the object instance here only, so I will use a static block, and inside the static block, I will use a try catch, and I'll create the method. I'll create the singleton instance, and if any exception occurs, I will catch that one, and I will, as of now, I will say print stack trace. So this is the second way of eagerly initializing the singleton pattern. But in this one also, like the problem is like if someone is not calling the get instance method, so there is a chance like it's not used, and so if it is not called means that if it is not using, so even it is not using, so we are creating the instance and there will be some wastage of memory. That's a problem. So rather than that, we will go for the lazy initialization. So where actually the object will be created inside the get instance method only, and it will be returned. So for that one actually, so I will remove that one static block. So first I will check if instance equal to null. So then I will create that instance. And so after coming out of the if statement, so I will return this instance. So this is good, but there is a problem with that. So because like if two threads at a simultaneous time call the get instance method, so thread one will check instance is equal to null, and the set thread two also check instance is null. So if both thread one and thread two get instance is null, so then they will go and create the two instances. So it's against to the singleton pattern. So what I'll do is to handle the multi-threading scenario. So I will use synchronized block, and I will get the class level lock. So and I will use instance equal to instance. So we achieve that locking system so that multiple threads will wait for something, and once getting the lock, they will go and create that one. The here also there is the same problem, like two threads came at the same time, and if they are checking for instance equal to null, thread one consider thread one got the lock of singleton class, and it will go and create the instance. By the same time, thread 2 is waiting for the lock. Once the thread 1 releases the lock, so thread 2 will acquire the lock, and it will go and create the instance once again. So for that one, so what I will do is even after getting the lock, so we will check for the instance equal to null. So if still instance is null, so then we will get the instance. Then we will create the instance, and then we will return that one. So in this one scenario, like in this scenario, so consider if two threads coming and checking for the instance is null. So thread one gets the first lock, consider. So, and it will go and it will check, okay, instance is null. So, and it will create the lock. Sorry, it will create the instance. So, and then it will come out and it will return this instance. At the same time, so whatever the thread 2 is waiting for the lock, so it will acquire the lock and it will go and it will check, okay, instance is null or not. At the line number 11, when it's checked, so it has got instance is null. But by the time when it is waiting for the lock, so thread 1 already created the instance. So this will become false. Like instance is not null now because already thread 1 created the instance. That's why it will not go into the get into the if block, and it will not create the instance. Rather, it will come at the line number 18 and it will return it. This is called as double locking synchronization way to create singleton objects. But in the Java 4 or 5 version, so even this method also has some problems with memory constraints. Like so if two threads are actually communicating, so there will not be a communication between the two threads of creating the memories. Like maybe a chance of my main memory and cache memory also problems. So even because of that, there is a chance of creating duplicate instances using the double lock also. So whatever they suggested from the Java 5 onwards, like rather than direct using the private static singleton instance, so use a keyword called volatile so that it will mainly add constraint on the memory so that each thread will communicate to other threads so that they will not have a misunderstanding like instance is null still, so that even that will solve the problem. So this is the one way. The second way is like the another way is like creating the uh, singleton objects by enum. Like I will have a sample one. Okay. So this is the way. So we have created an enum called as a singleton enum and instance. We have declared one variable called instance. So if you use singleton enum dot instance, so it will provide the singleton enum. So this is the simplest way, whatever they provide from the Java 5 onwards, like as from the Java docs. So singleton, that's a enum, make sure that it will create only single instance for the provided variable. And it will make sure that it will not be break through serialization and all things. Yeah, this is the way we create singleton objects. The next is the different ways to break the singleton. Like we have created the singleton class, and we know that we taken care about creating the instance by using the double check locking also. So even though how to break this, so there are different ways to break the singleton pattern. So those are all through reflection and the cloning. We can use the clone method and we can break the singleton pattern, and also in the serialization. So we'll go through one by one, like how we can break through reflection. So even reflection also we can use the reflection classes to create the new instances. Like consider we have a singleton class. So if we use singleton dot class that get declared constructor, so then we will get a constructor of singleton. So, and even though singleton constructor, we have made it private, so we can set it to accessible. We can make the set accessible to true. And if we call constructor dot new instance, then we will get an singleton object. That means there is a chance of breaking this one. So to overcome this one, so what we can do is in the constructor, we will have a check like if instance is not equal to null. Like the object is whenever the object is creating, so it will be calling the single constructor. So in that constructor, we will check is the instance is already created or not. So if instance is created, so then we will say we'll throw an exception from new runtime exception, and we can say instance already exists. So this will actually make sure that uh, the code should not be, the singleton object should not be broken by the reflection. This is the one way. The next one is, so the cloning and the serialization. Like we can break it to cloning or maybe serialization. Like if some purpose we have made our singleton classes to implement the clonable interface, then so we must should take care about that clone method so that clone method has to return the same instance the whatever they already created, or maybe it should throw an exception saying that the clone method should not be supported for this class. The next one is serialization. So when the serialization, when it comes to the deserialization, it will actually creates a new object. So for that one, so we will add a method called read resolve method. So there is a method, so we can add that method, read resolve method, so that we made sure that during the serialization or maybe deserialization, so JVM will look at this read resolve method inside the class and it will execute as we suggested in the method. So for that one, so what I'll do is I will have a protected method, and so it is the return type is object, and read resolve. So, and I will, rather than throwing another, I will say return the instance. So that one means whenever serialization happens, so the JVM look for this method and it will check, okay, read result method is provided by the programmer itself. So, and it will go and it will check, okay, the already existing instance has to be returned. So it will return that instance. So this is the way actually we have the different ways to create the singleton pattern objects and the different ways to break the singleton pattern objects. So I hope this will help somehow. And thanks for watching. Have a good day.